anonymization with machine learning. And since I am from the here on the behalf of the federal administration, I will start with the legal basis, because everything we do is to have a legal basis, and we only act in that scope. So we have many laws that govern our actions at the Federal Archives, but there are two main laws that are relevant for us and for this topic. It's first of all the Federal Act on Archiving, which says that the archive records of the Confederation must become available for consultation by the general public free of charge after the expiry of a retention period of 30 years. But this retention period rises to 50 years if a document contains sensitive personal data or personality profiles. It's one condition. And the second condition is that the document is classified according to the names of people. So you can search the document by the name of a person. But there's a second law. It's an ordinance to the first law that says that even finding aids, which as such contain sensitive personal data or personality profiles, shall only be published after the expiry of the retention period. So basically this means that we are legally required to make administrative data accessible to the public, but at the same time we have to manage data protection, individuality protection, and this even in metadata. So how do we do that? We decided to anonymize much of our data, which we weren't able to publish up to now. We had about 1.8 million records on hold, of which we weren't even allowed to say that they existed, because we couldn't publish the metadata on the website. We did this for the records that were, we had to make this for the records that were more recent than 50 years, which is a lot of time. Now, how does this problem look like, and how is it specific and relevant for named entity recognition? This is what an archival metadata looks like. There's other metadata, but this is basically the central part of it. As you see, there are no grammatical sentences. There are multiple languages combined in a single text sequence. The data metadata has an embedded tree structure, so we had no state-of-the-art approach or off-the-shelf pre-trained model for SPACY, Stanford NER tree tagger, Aaron Integer, you name it. So we had to invent something else. To give you an example of the problem that you can have with this archival tree structure, or the dangers that you can have, is, for example, well, of course you can have titles with direct sensitive information pertaining to a legal person. So you have a SMPO GmbH who's accused of fraud fiscale, so you immediately see this is sensitive data, so because of tax evasion. But you also have more complex cases where you have a title like Marianne, par exemple, une ville, born on the sometimes in the 2005. So this is okay. This is no sensible metadata. But the problem is this name appears in an archival context, where you see it's actually a whole archival fonts, which is dedicated to the Strafverfahren-Zentralstelle. So basically you can know just by the apparition of this name of this person in this archival tree that this person has been subject to legal prosecution, which is highly sensitive. So we had to deal with that, and again the solution for us was to anonymize the data. So we were able to, we've tested a couple of solutions on our sides, and eventually we decided to turn to the University of Zurich, to the Text Crunching Center, which I think changed its name. It's between which was led by Dr. Tilly Allendorf, who's sitting also in this room, and by Dr. Gerold Schneider. And what we did is to we submitted them a XML annotated training dataset. In which we identified, well, in the titles, personal identifiers, personal identifying tokens of 4 classes, like natural persons, legal entities, which can be companies or associations, birth dates. Of course, if you live in a small town and just someone says it's in a small town somewhere in the Campagne of Switzerland, and you have a birth date, you can very easily identify the person even if you don't have the name. So it's also sensible information. Of course, social security numbers, military registration numbers, or other alphanumeric identifiers, or CAID number, which allows you, which is a registry for the foreigners that is held by the Home Department of Federal Affairs. And also there is an open tag, which is not annotated, but it's everything else where the token does not represent sensible information or personal identifier. There's another part, there's a document reference, and there's also the hierarchy, which serves also to the training of the data, of the prediction of the presence of names or personal identifiers in the data. And the tailored solution that we became, there are many aspects to that diverged from standard or out-of-the-box models. So I'm not going to describe everything about it, but give you some examples that were specific for our needs in the archives. Let's take an example. You have this phrase, Gérimont 1926, and the question is whether Gérimont belongs to one of the sensitive categories, whether it's, for example, a person name. So you can say it's with 19% probability to have the class N, 9% probability to have the class G, so a legal person, 1% probability of being of class D, a date, and 72% probability of being open, so not a personal identifier. So a standard named entity recognition model would say, okay, this is not a personal identifier, 72%, but in our case, we have to protect personal identities. So in the tailored algorithm which we convened on, we decided to boost recall very much at the cost of precision by determining that there is a certain threshold up from which we say, okay, this is probability enough to decide the N class or a personal identifier classes to be attributed to this word. Of course, we can, the cost for precision is very high, and one interesting thing that we've observed when we've analyzed or started to work with this data is that if you make this threshold higher, you gain linearly in recall, but if you make it lower, you lose or almost exponentially in precision. So this is a very sensitive thing, this threshold that you would fixate at which you will decide, okay, from this point on, this is a personal identifier. Another aspect that we've gotten in this collaboration was a ensemble system. So again, for higher security, we don't rely on one single algorithm, but there's a triple checking by using conditional random fields, support vector machines, and multi-level perceptron. And again, for example, if you take this case of Gérimont, what class does Gérimont belong to? The CRF system would say, okay, it's nothing to 55%, and N class, like a person name, at 8%. The SVM system would say 48%, again, open class, 9% for the person name, and the MLP system would say 46% open and 11% a person's name. Again, if you were making standard named entity recognition and not data anonymization, you would go for the O. But again, we decide there's this 10% threshold or some threshold which we fixate, from which we say, okay, one of the systems has told it was a personal identifier, so we go for the personal identifier. So what we've got from this system were actually quite good and very satisfying results for us. We had an overall precision, overall recall, because recall is the most important value for us. It's of 97.4%, which is lower than almost lower, or actually lower in experiences than human errors that can be made in annotations or freeing data that actually shouldn't be freed. So it's a satisfying number. And an overall precision of 93.1%, so we still get good, not over-redacting of our data. And this can be achieved with 17% for N detection, so person names, and 10% threshold for the legal person detection, which are actually quite high numbers. So that's why we didn't lose that much precision only in the field of legal entities, which turned out to be much more difficult to detect because it's, for example, the confusion between legal entities and person names is very high, and you can also have high confusions between legal entities and names of places. Also a good thing for us from the point of view of well, the economy, because the whole point of the task was to not to have to do this these 1.8 million records by hand, because we wouldn't have the resources to do that in the federal administration. So it turned out that we only with 2,000 annotated sentences or metadata items, we had a system that showed this capability and this kind of precision. Actually, if you look at the evolution of the F-score, already at half of the data we reach a peak in the training quality. So actually you need only 1,000 annotated records and you can already start to work with that. There just seems to be some systematicity or enough regularity in the data in the metadata of the archives to achieve that result. The only problem again was the or more difficult aspect was the annotation of the legal persons, the G class, where the F-score peaked at much lower levels. We also developed something else. In the discussion and the collaboration, it's one of the interesting things when you collaborate with specialists in computer linguistics, like most of you are, and you're a project manager in the federal administration. When you try to evaluate the quality of the work and you get F-scores and recall and precision, it's not immediately comprehensible to the evaluators and to all the people on the team, like experts in other fields that have to deal with this with those results and decide, okay, do we go in production or don't we? We have to put it forward to management. And of course, there are 3 different cases. So this is no-go because we would publish sensible data. This is also, well, we can do that legally, but there is no point in publishing a archival data structure like this one. And this would be the ideal. And how do I detect otherwise than by F-score, a very synthetic number, where I am situated between those 3 extreme cases? And one of the tools we've developed doesn't seem understandable at first, but here you have the percent of proportion of the redacted numbers, of the redacted words in a meta title. So here you have the number of meta titles or the metadata items that were redacted at 100%, which could be bad. But with this visual indicator, we can see that in the light gray, you have the proportion of redacted characters across all records of these groups. And you have, in the dark gray, you have the proportion of wrongly redacted characters in this group, which means, okay, we have actually quite a lot of records that were 100% redacted, so totally blacked out. But if you look at the annotated data, well, they were rightfully so. So the result is good, even though we have a total blackening or total redacting. It is acceptable because it must have been so. So it's a good visual assessment to see, okay, how much of our data has been redacted? Is it worthwhile to publish it? And is there any problem where this proportion of this dark gray area would be too large, or where we would have wrongfully redacted too much tokens in a metadata. I wanted to make a live presentation. I think we don't have time for that, but there is we've published the whole product on GitHub, so you can access it on this page. And there's also a Python notebook, and you can play around with the whole algorithm. The training data, we've already prepared the training data that is also on the GitHub site. So I invite you to try this out if you have a anonymization task in your office or in your company. Thank you.
Thank you very much. Questions?
Yes?
Yeah. The goal of this, if I understand correctly, is to anonymize. It started the title or this metadata of the archives, but afterwards, do you also try to anonymize the files behind, or is it this?
No, it was really the problem of the metadata, because the files, it's a whole different story. You can, it's actually, it would be easier to anonymize the files, because then you can use standard models, because many people have already solved this task. But it was difficult for this metadata aspect, where you don't have natural sentences.
But I don't understand why, like, from a legal point of view, this is more important to anonymize the metadata.
Because the people couldn't even search for, let's say, I can give you an example like this. Let's say you would search for a keyword like Verfahren gegen, out of some interest, or you want to see how many records, because you deploy the archival tree. I want to see, well, what's inside there. And up to now, all of this had to be just totally hidden. We couldn't show anything. Well, we could show numbers of totals of those records. But let's say this is the name of a city, La Città. It can be interesting that there have been andere Angelegenheiten des Bundes, Bundesstelle. It's not a very interesting information, but let's say there was a Strafverfahren-Zentralstelle. There's a record for this city. It's an interesting information already. So you have already something, and up to now we had really nothing. So that's why we needed to do that. Because if you there's also one other thing, and it goes back to your question of the primary data. You can only ask for the, you can ask the archives even prior to the end of the retention period for a consultation permission. And this goes to the corresponding office, and you can, in many cases, you become this possibility. For example, if you're a researcher on a specific topic or something. But if you don't have the metadata entry, you cannot even try to ask, okay, I think I would really like to know what were the cases of tax evasion, fraud in this city, because I'm working on a journal article or something about it, or making on a research project. And if you don't have this, you can't even order the file.
I just wanted to ask, is this something that is already in use or will be used soon?
It's in production. We've anonymized the data, and as I said, we've been able to publish 1.8 million metadata records thanks to that. So yeah, it was a huge gain in working time that we had.
Have you also done any kind of human post-processing, like
yeah, we did. Yeah.
Maybe here we already did it with taking out information, or where the models were not certain enough, or
yeah, we did, but of course it has to be. It's on the level of a Stichprobe, like a.
Understood.
Yeah, because it's the mass of the data is so gigantic. But of course, there are some cases in which some very sensitive contexts in which we looked much more specifically whether something has been under-redacted was the first point of concern, and the next point of concern is, okay, is there over-redaction happening? And this is, of course, something that we can also, as soon as we see something, we do correct it. But it's, actually, there's one task at hand right now, because there's another aspect. You have in many cases where you are still in the retention period, there's a person in the record, and you say, okay, for all security, I just will hide the name of the person. but in many cases the context is not sensitive at all. It's like professor this and that has become honoris causa of the APFL or the ETH. This is not a sensitive information, it's public information, but you also hide it. And the next task for us is to not this question of named entities, but the question of is the context sensitive or not. So this is the next thing we want to launch as a project.
Thank you.
Yeah.
Thanks for the presentation. I'm not sure, maybe I've missed it, but who is using this metadata?
Everybody who searches on the site of the Swiss Federal Archives. So you have a website.
So it's essentially the general public, because I was thinking, like the under or over reduction, it is an important point, particularly when the media jumps on it. But if you could kind of do like a feedback loop where people would, kind of like label, annotate records that they feel are under-redacted or over-redacted, and have some kind of feedback loop.
We do invite people to signal something, but it's not it's not embedded in the system. Yeah.
Just as an idea, because I know they did some sort of like community thing with hate speech in University of Zurich and
Yeah.
Potsdam.
Yeah.
And it worked out really well for them.
Yeah. Okay. Thank you.
I also have one question. At the beginning you mentioned this problem of having different levels on the hierarchy,
Yeah.
and only the combination of the levels gives critical information.
Yeah.
How did you solve that? I didn't get that.
We solved it by making a kind of a hyper metadata, or we just decided the whole structure is a sentence. But then it turned out that separating the title from the hierarchy, so this would be this is the archival tree,
Yeah.
and this is the title, but this is also considered by the model.
Okay. So you take this also.
Yeah, and of course in the next step, so at this step, this has been considered by the model just to say it's a predictor. It gives a probability of with how much probability there are person names in this part. So this is the only use that has been made of that up to now. But of course, this is a very important aspect when you can say on the decision, is this sensitive or not? Because if it's not sensitive, it's like Mr. or Madam gained a sports competition. It's already in the news, so you don't care about having person names in the tag. So that would be the next step.
Any other questions? If not, then thanks.